All right, my patient students, I appreciate you guys so much. I am going to try and run through kind of quickly 2-1, 2-2, and 2-3 for the week. So they should be pretty short lessons. That's my goal. And right now, this lesson is all about writing equations. And when we write equations, that's important to know how to do, because when we read a word problem, like on your EOC or any math word problem, really, you have to know how to extract the information we need, right? When we solve math, we certainly don't write out a long paragraph to solve math. We just write down the equations, right? So we have to know what information to pull out. So we got to be able to translate words into a math equation. So it says writing equations is one strategy to solving word problems or solving problems. So we're going to say writing equations, strategy for solving problems. Okay? You can use a variable to represent an unspecified number. So that's important. Whenever we don't know what something is, the value of something, we use a variable to represent it, a number or measure. And then we can write a verbal expression in an algebraic expression. So that's the last step. Once we've kind of written down what we're going to use to represent pieces of information, then we can write it out in an equation. All right, so translate each sentence into an equation or a formula. So they give us some examples right here, and you guys have this study guide. You can print it out. You don't have to, but it's here blank for you, so you can go back and look at it, not just in the video. 10 times a number x is equal to 2.8 times the difference y minus z. Right? So that's a lot of stuff. So how do we know how to translate it, right? And they've done it here for us. So what I would tell you to do, what I would recommend, is figuring out a way to mark stuff. So for me, I'm going to circle each term. So 10 is a term, it's a number. Each operation, I'm gonna like draw the operation symbol above it. So it says times, so I'm gonna put a little x there for times. A number x, that's all one term, it just means x, is equal to, that's my equal sign, 2.8, that's a term, a number, times the difference y minus z. So we need to know how to write that. Difference means we're subtracting. So really we didn't have to write the word minus here, but they did. That's a pet peeve of mine. You could have just said the difference of y and z, but y minus z. So I'm going to rewrite that and just put y minus z. Okay, so now I have to write it out, which they've already done for me. 10 times a number x, so 10 times x, is equal to 2.8 times y minus z. So since I have to subtract y minus z and then multiply it by 2.8, I'm going to put it in parentheses. Because if I just put y minus z, it would look like I'm supposed to multiply 2.8. See if I did 2.8y minus z. It looks like I'm first supposed to multiply and then subtract, but I'm not. First thing I'm supposed to do is subtract, and then whatever I get here, I multiply. So make sure you're writing this out correctly. B, a number m, so that's one term, minus 8 is another term, is the same as, that's equals, a number n, that's a term, divided by 2. So divided by, and then my term, 2, right? So I've circled my terms, I've written out my operations, so I'm going to start out, and they've already written it here, a number m minus 8 is the same as the number n divided by 2. Or you could write it out sideways, divided by 2. Either one of these is correct. So that's all we're doing here, that's it. So we have examples we're going to do at the bottom. Now here's a few word problems we'll do real quick. The area of a rectangle equals the length times the width. Translate this sentence into a formula. A formula is just an equation that represents kind of a general rule in algebra or in geometry. So for area, that's a formula. For any shape, any three-dimensional shape, we can find, or two-dimensional shape, we can find the area of. 3D would be volume. Area of a rectangle equals length times the width. So area of a rectangle, that's one term, equals the length times the width. So I've circled my terms, and I've written my signs above them, right? So area of a rectangle, they're just going to call it A equals length. I'll just put an L for length. When you don't know what something's worth, you just use a variable to represent it, times width. Be careful using this little X whenever you're doing multiplication and you're using variables, because it can easily look like the variable X, right? And we don't want it to look like the letter X, we want it to look like a times. So a lot of times you'll either use parentheses or a little dot to represent times. So here I have exactly what they have. A equals L times W. The formula for the area of a rectangle is A equals L times W. Okay, and then before we get into the bottom real quick, early on in algebra, you guys kind of learn this template for how to solve a word problem, and it breaks it down into 4 steps. I kind of name my steps a little bit differently. That's just me. Here it says use the 4-step problem solving plan. Population. The population of the country in July 2007 was about 301 million, and the land area of the country was about 3,500,000 square miles. Find the average number of people per square mile in the United States. So step 1 is to read the equation. My step 1 is ask yourself, what do we know? What do you know? So based off of this problem, what do we know? We know that the population of the United States is 301 million, and we know the size of the United States is 3,500,000 square miles. What do we want to know? Step 2. My step 2 is what do we want to know? So then we got to kind of come up with a plan, right? Okay, so we know some stuff. Now what are we trying to do with that stuff that we know? So here we're trying to figure out how many people there are per 1 square mile. So first thing I can do here is write down how many people there are. 301,000,000. That's people. And then that's out of, I'm going to write a ratio, because a ratio is a relationship between 2 numbers. Doesn't really matter which goes on the top, which goes on the bottom. It's just a relationship. So I'm going to put people on top and then the size of the land on the bottom. So that's 3,500,000 square miles. I'm going to put miles squared like that. So this is the ratio or the relationship that we know. What do we want to know? We want to know what the top number is going to be if the bottom number is 1. That's what we're trying to figure out. So we want the same exact ratio, but instead of being out of 3,500,000, I just want to know what the ratio is if it's out of 1. So what do I need to do here in order to get 1 on the bottom? So once we kind of write our equation, and they've done it here for us kind of a different way. Let P represent the number of people per square mile. This many square miles times the number of people per square mile equals this much. I would represent it this way and say it equals people, right? It's the same difference. So 301 million people divided by 3,500,000 square miles. I want to make miles on the bottom 1, so then the question becomes how many people are there out of 1 square mile. So I am still solving for P. So all I'm really doing here is dividing, and that'll give me the number of people per square mile. So step 3, I agree with this one, is solve. We have to solve our problem here. So if I divided this top number by this bottom number, I would get 86. And then once you get your answer, of course, you always want to check it. So that's our 4th step 4. We always want to check ourselves. So if I went back and divided this and got 86, I could multiply 86 times 3,500, or 3,500,000, and I would get 301 million, right? This divided by this equals this guy. This times this equals this guy. We just kind of went forwards and backwards. It's the same thing they did here, just a different order. Okay, so that's kind of our 4-step plan. What do we know? What do we want to know? Okay, go ahead and set up your equation and figure it out, and then check yourself. So step 3 is like the most important. That's where the actual math comes in. All right, so real quick, some of these down here, we're just translating. We're seeing if we can pull out of a word problem like up here, if we can figure out what am I trying to write down? What's the equation I'm trying to come up with, right? So here, 3 times the number t minus 12 equals 40. I'm going to do that same thing I told you guys I did before. I'm going to circle my terms and put the symbols above my operations. So 3 times a number t minus 12 equals 40. And then out here to the side, I can actually write it down, right? 3 times a number t, so 3t, minus 12 equals 40. And it doesn't say to solve, it just says to write out the equation. Okay, number 2, 1/2 of. So 1/2 is a number. Remember back when we went over like different words we can use, different vocabulary when we're translating algebraic into verbal and verbal to algebraic, and we said the word of works for multiplication when we're using fractions. So a fraction of means times the difference of A and B. So difference is subtraction, right? What two things are we subtracting? I didn't mean to circle that. I shouldn't have circled it. It's not a term. I just wanted to point to it. Whenever you have the difference and then you have the word and, that minus sign from the word difference goes where the word and is. So I do want to circle A and B. And then is 54. Sorry, I didn't mean to circle this and. Okay, so 1/2 times the difference of A and B. So remember, just like up top here, I had to, where were we at? I'm losing it. Oh, up here. I had to put parentheses around it because I wanted to show that I was subtracting first, and then whatever I got there, I'm multiplying it by 2.8. Same thing down here. Use the examples we're doing in the work that you're going to do on your own, right? Don't reinvent the wheel. Look at what we've already done. So 1/2 of the difference of A and B, so A minus B, is 54. Okay, next one, 3 times the sum of D and 4, so this plus goes where the and is, and I'm adding D and 4, equals 32. Okay, so 3 times the sum of D and 4, so I got to show D plus 4, in parentheses, 3 times the sum of D and 4 is 32. And number 4, the area of a circle is, so that's one term, is equals the product of, this means I'm multiplying, and it's going to list the two things that I'm multiplying. So it's going to have the word and in between, so I'm multiplying this guy right here and this whole thing right here. So the area of a circle, I'm going to say that's A, is the product of what two things am I multiplying? Pi and radius squared. So I'm multiplying pi times r squared. Or you could just put pi r squared. You don't have to put the little dot in there. Hopefully this is making sense. Number 5, Lou wants to lose weight to audition for the part in a play. He weighs 160 pounds now. He wants to weigh 150 pounds. A, if P represents the number of pounds he wants to lose, write an equation to represent this situation. So remember, what do we know? What do we want to know? How do we solve it? That's where A is. It's stopping at step 3. We're not quite solving it yet. So what do we know, first of all? We know that he weighs 150 pounds. And we know that 160, and he wants to weigh 150. Okay, what do we want to know? We want to know how many pounds he needs to lose. P to lose. So I need to write an equation showing that he needs to go from 160 to 150, losing P number of pounds, right? So 160 minus however many pounds he has to lose needs to land him at 150 pounds. There's my equation. And then B, how many pounds does he need to lose? Now I'm actually solving it, right? I have to solve for P now. So 160 minus P equals 150. You can solve this a few different ways. I do not like to deal with negative anything, so I don't want to leave P negative. So for me, first thing I'm going to do is get rid of negative P by adding P on both sides of my equal sign. That cancels. And it doesn't really help me simplify anything, but it does help me move p so that now it's positive. So I have 150 plus p. So now p is positive, and all I have to do is get rid of this 150. So I have to subtract both sides of my equation by 150, and I get 10 equals p. So that means he needs to lose 10 pounds. Which makes sense, right? Duh. He's 160, lose 10, you're 150. Makes sense. All right, back side, almost done. Here, writing equations. Basically, now we're going to flip-flop it. So we just took verbal, and we had to write it into an equation. Now we're going to start with an equation and put it in our own words. We're changing it to verbal, right? And why would we ever need to do that? There could be some instances where you have to extract information and then write your own word problem with it. Also, understanding how it works forwards and backwards helps you understand it the way we just did it, right? If you know how to write your own word problem, then when you read a word problem, you're going to know what it means, right? That's the idea. So just to kind of review real quick, an expression is like this. There's no equal sign. 2x minus 4, that's an expression. An equation has an equal sign, like equal, equation. It's got an equal sign. That's the only difference between an expression and an equation. So when it says write an equation, you got to have an equal sign. When it says write an expression, you do not. All right. Translate each equation into a sentence. So we got to think about what we just came from, right? I want to look at each term, and I want to use the operations happening. I want to use words for those operations, right? So the first term here, 4n, 4 times n, minus 8, that's our other term, equals 12. Right? So I took this and I just wrote it out in words, but literally the same way that I went backwards, right? When I looked at the sentence, I separated the terms out, gave the little signals for plus, minus, equal, whatever the operation is. I'm just going opposite now. Okay, here, b. It looks like a squared plus b squared equals c squared. So I would say, since I'm adding two things, what two things am I adding? The sum of, and now I have to list my two things, a squared, or the square of a, and b squared, or the square of b, the squares of a and b, is equals the square of c, or you could say c squared. This is just one way of doing it, right? So that's one way of writing a verbal statement. So let's do a few of these. I actually don't have room to write these out. I did want to pick, I'll do that one. I'm just going to ignore those and use the room next to them to write. Okay, so number 1, 4a minus 5 equals 23. You cannot write 4a minus 5 equals 23. If you wrote 4a, that's wrong, because what's happening between the 4 and the a? Are they getting married? Are they going on vacation? Like, what are they doing? No, we're just multiplying them, right? 4 times a. So I'm going to say 4 times a, and then I subtracted 5, so minus 5. And then equals 23, you could say is 23. You could say equals 23. You could also say 5 less than 4 times a, right? Because we started with 4 times a and then we took away 5. 5 less than 4 times a. That's another way of saying it. Equals 23. There's a whole bunch of different words you can use, and they're not wrong. There's just different ways. Number 3, we're multiplying all 3 terms here, and that equals 24. So I will say the product of, and now I'm just going to list the 3 things that I'm finding the product of, that I'm multiplying, 6x and y equals, or is, 24. Done. And you do not have to spell out the numbers. You can just write the number. P plus 3 equals 2p, right? I can't say that. I can't say equals 2p. I have to tell what the operation here is. The first thing I'm going to do, I could either say p plus 3. I'm going to say 3 more than p. Remember that more than and less than? Whatever's in front of the phrase goes at the end of the expression. So here, 3 more than what? The what is what we write first. So 3 more than what? P. P plus 3. 3 more than p. equals or is, and you could say the product of 2 and p. You could say 2 times p. Whatever you feel more comfortable or more natural saying. Number 7, 100 minus 2 times x equals 80. 100, I don't know why I just wrote times. 100 minus 2 times, you could say x or you could say a number x, it doesn't matter. I'll say a number x is 80. Or you could say equals 80, it doesn't really matter. I don't know, I was trying to talk and think and write at the same time and I messed it up. You ever have those days? Number 9, p squared minus 2 times p equals 9. So p squared, or you could say the square of p. I don't really like saying that. I like saying p squared minus 2 times p. Another way of saying 2 times something is you could say twice something. Because think about it, if you do something 2 times, you do it twice. So 2 times p is twice p. Equals, or is, 9. And the last one, we have a fraction here that's getting multiplied, so we can say a number v, or I'm just going to say v, equals 1/3. And whenever we're multiplying a fraction, I'm going to say of, and then the product of b and h. Or we could say b times h, or however you want to do it. I'll say 1/3 of b times h. Okay, hopefully that helped. And if you have any questions, let me know. Thanks.